This is our DFT170 final project for spring 2025 for engineering, graphics, and design. I'm Austin Jordan. My partners are Maddox Bush and Ryan Clark, and we have been assigned to draw, design, assemble, simulate, and animate our Boe-Bot. We started off this process of this project by dimensioning and taking pictures of different views, as you can see in figures 1 and 2. We also looked at different parts and brainstormed how we could split up the Boe-Bot into different pieces to make the SolidWorks modeling more simple. Next, we sketched out 3 orthographic views in figures 3, 4, and 5. Those views are front, right side, and top. Then we sketched our isometric view to get the most detail out of our sketches.
For figure 7, this is the back ball of our project. We used extrude Boe base and extrude cut for the center hole. For figure 8, this is the top tray of our project. We used extrude Boe base, extrude cut, and hole wizards. For figure 9 of our SolidWorks project of the motor, we used extrude Boe base, extrude cut, and mirror for the sides. For the wheels of our project, we used extrude Boe base, extrude cut, circular pattern, and fillets. For figure 11, the bottom base, we used extrude Boe base, extrude cut, fillets, and hole wizards. For figure 12, we used extrude cut and extrude Boe base for the back rod. And for figure 13, the cylinder supports, we used extrude Boe base and extrude cut.
In order to properly assemble the moving tray, we use several kinds of mates, including coincident and concentric mates. Concentric mates were our most common because much of our assembly is made of circular, cylindrical, and spherical objects. You can also see an exploded model of our model in figure 15. Here we have our drawing document, which consists of the front, top, right side, and isometric views of our assembly. We also included an auxiliary view, a detailed view, and a section view. The section view offers a vertical cross-section of our model, and the detail view shows a closer look at the fasteners used to secure the assembly. Figure 17 shows our force simulation using a force of 10 newtons on the top tray of the model. As you can see, the tray started to fail and fold in on itself. In order to properly animate the model, we had to be sure that all of our mates were properly placed and working correctly. We used motors on both wheels and the front ball to make them spin at a constant speed of 25 rotations per minute. We started our project by brainstorming and sketching out all necessary parts. We then moved on to modeling all of the parts using extrudes and extrude cuts. To create the assembly, we used concentric and coincident mates to complete the assembly. We then created our drawing document and ran our simulations. Then finally we animated all the moving pieces.